Okay, we're going to do a little bit of naming, and because we're doing some naming, it's going to take just a little bit of time because we have to name them. Then we have to add the stereochemical information. So now we're at that point in the semester where not only do we have to be able to name compounds, which means all the rules for IUPAC naming, we have to be able to add the stereochemical information. And in the first example, you have a ring, and you might want to try cis or trans, but cis or trans only works if there's only two groups to look at, right? Because if it's cis and trans means same direction or opposite directions, and if there's three groups, then you can't really say same or opposite. So we have to then specify the configuration of all three stereocenters. And so I do have stereocenters here, here, and here for the first one. And so let's go ahead and name it. So I would start with 1, 2, 3, 4, 5, or I could go 1, 2, 3, 4. Seems like 1, 2, 3, 4 is the way to do it. And so that's the way I should name it. So I'm going to go 1, 2, 3, 4 in the red direction. 1, 2, 3, 4. And so it's a cyclohexane. Okay, what do I have with this cyclohexane? I have a 1, and it's a 1-methyl ethyl at that position. I'm going a little bit faster because at this point you should be able to identify these groups. If you can't, go back and do a little bit more practice from chapter 4. All right, the position at 2, that's 2-iodo. And at 4, that's going to be a methyl group. So we got everything together. So we could even write the name. We could start it out and say we've got, what comes first? I or M? I had to think about it for a second. I comes first. So we've got 2-iodo, 4-methyl, 1,1-methyl ethyl, cyclohexane. Now we got to add all the stereochemical information. In order to do that, we need the stereochemistry. Okay, so let's take a look at each of these chiral centers and decide what the stereochemistry actually is. And so let me go ahead and bring in my hydrogens so that I can label them appropriately. At this point, it's pretty clear that the hydrogens will be the 4 priority group. They're going to be the lowest priority. Okay, let's start with the number 1 position, the 1-methyl ethyl. And so I've got carbon, carbon, and carbon. And so they are all tied. And so I need to think about this carbon. I need to think about this carbon. And I need to think about this carbon. And so let's do it. The red carbon is connected to, and we're going further down the chain. The red carbon is connected to 2 hydrogens and a carbon. The blue carbon is connected to a hydrogen and 2 carbons. And then the purple carbon is connected to a hydrogen, a carbon, and an iodide. So this is it. We've got all the tie, we've got the triple tie broken. And so now we know the priorities. Iodine beats everything. It's the heaviest. So it's the top priority. So this is the 1 priority direction. The next priority direction is the blue carbon. That's the methyl ethyl group. So that's 2. And the last one is this direction, 3. And so now we have all 4. And so let's go ahead and go 1, 2, 3. That is a counterclockwise direction, but take a look. We have our lowest priority group is not pointing away from us. It's pointing towards us. So we actually need to switch our configuration. So instead of saying counterclockwise is S, we will say counterclockwise is S, but it's in the wrong direction. So I'm getting the opposite answer than I should. The actual configuration of that stereocenter is R. Okay, let's take a look. Let's keep going. I'm going to erase some things in order to make some room. All right, so let's go ahead and redraw that hydrogen. It's the fourth group. Let's take a look at the iodine. That's obviously group number one. It's the heaviest. And let's see if we can do this one without really writing down a tiebreaker. Yes, I've got a carbon here and a carbon there. The carbon towards the top, the purple carbon, that's connected to a carbon and two hydrogens. And the carbon to the bottom is connected to two carbons and one hydrogen. So this is a higher priority group. So this is my 2 and this is my 3. And this is something that you can take to the bank, right? If there is more branching on a carbon and the tiebreaker is between carbons, the carbon that has more branching is higher priority. And so that's what I typically use. All right, and so let's do it again. We got 1, 2, 3. This is a counterclockwise direction, and the lowest priority group is pointing away from us. So this is actually an S configuration. We don't need to do any reversing. So I've got S there. All right, let me do some erasing so I can make some room. Let's go up to the top. What's going on at the top there? I've got 4. Let's do the other priority groups. Okay, the methyl group is going to be the lowest priority group, and I hope you see that at this point because that carbon is connected to only hydrogens. So let's figure out what's going on with these two CH2 groups. Well, we have to continue to move around the circle. So that's a CH2 there, and that's a CH, and that CH is also connected to an iodine. So that makes this priority number 1, and that makes this one priority number 2. If we were to take the 2 purple and red carbons and write a list, for the purple list, we would get carbon, hydrogen, and hydrogen. And for the red list, we would get carbon, hydrogen, and iodine. And so we're definitely winning with the iodine there. Okay, so we've got that figured out. So what's the configuration? It's 1, 2, 3. That's a counterclockwise direction. And so I've got an S configuration there, and the lowest priority group is pointing away from us. So what do I end up with? What are the stereo configuration of those different spots? So the iota, so I had 2, so the methyl ethyl group is R, so I got 1 R. The iota group is S, so I've got 2 S. Do that one. And the methyl group, the top position is in S, so I have 4 S there. So let me actually make some room. Move this guy over just a little bit. And so now I can do this again. 1R, 2S, 4S. And that's the name. Okay. Got that one done. Now let's try this next one. Well, this one's a little bit different projection, so we need to figure that out. It looks like I've got a 1, 2, 3, 4 carbon chain. So this is a butane of some type. And so let's see what I've got as far as chiral centers are concerned. It looks like I've got 2 of them. That's a chiral center, and this is a chiral center. And so here's my lowest priority group in each case. They're both pointing towards me, so I'll have to reverse my configuration. So let's work on the top one. The top one, bromine, is clearly the highest priority. What's the next highest priority? Well, remember, the carbons with more branching are going to have higher priority. So that means that this one is going to be 2, and this one is going to be 3. So I end up with 1, 2, 3, the S direction, but remember, it's actually R because the group is pointing towards me. The lowest priority group is pointing towards me. Okay, we know it's R, so let's go ahead and take a look at the next carbon. This is priority group number 4. Chlorine is going to be the heaviest atom that carbon's connected to. That's priority number 1. And we can say again, the higher the branching, the higher the priority. So now we have 1, 2, 3. That's a counterclockwise direction again, but the lowest priority group is facing towards us. That's the wrong direction. So that we would reverse our configuration there and get R. Now the rest is just naming the butane. And so I need to number the butane. Is it 1, 2, 3, 4? Or is it the other direction? Well, it's 1, 2, 3, 4 because butane comes before, or because bromine comes before chlorine alphabetically. So what do I end up with? I end up with 2R, 3R, 2 bromo, 3 chlorobutane. That's what we got there. Okay. Now, how do I draw these other structures? So I'm going to go ahead and get rid of that so I have some room. And so drawing structures is, again, always a little bit easier than naming structures. So I've got a pentane, 1, 2, 3, 4, 5. I've got 2 methyl groups, and I've got 1 at the 2 position, and I've got 1 at the 3 position. And so it looks like one of those is chiral and one of them isn't. Well, which one's chiral? The one at the 2 position isn't chiral because it's going to be connected to. Okay, so we've identified that the methyl group at the 2 position isn't going to mean a chiral carbon. So I'm not going to go ahead and show that, but the 3 position is chiral. And so let me show you what I do. What I do is I just try it and I say, okay, let me just assign this one as CH, as hydrogen, and I'll assign this one as CH3. And so the question is now I know that I've got a 2,3 dimethyl pentane. The question is, did I draw the right one? And so what we want to do is we just want to do a quick specification and see if we did. 4, this will be 3. The branching is higher on the right, so that one's going to be 1. This one's going to be 2. I would get 1, 2, 3. Our group is pointing in the lowest priority group is pointing away from us. So this is a counterclockwise arrow, so it would be S. Oh, so it turns out that we didn't do it right. So that's not the right picture. So what do we do? Well, all we have to do is switch. And so once we switch, remember, switching the position of 2 groups gives us the enantiomer, and that's what we were looking for. So we're there. What about propane? 1, 2, 3. And so it looks like I've got a 1 chloro, 2 fluoro, propane. So at the 1 position, I have a chlorine. Okay. At the 2 position, I have a fluorine, and that's where my chiral center is. Again, I'm just going to try it out, and let's see if I get the right answer. So this is 4. This one is 1. This one is 3, and this one is 2. And so I would get 1, 2, 3. That's the R direction. That's the clockwise direction. The lowest priority group is pointing away from us. So that just means I drew the wrong one. So all I have to do is switch the fluorine and the hydrogen, and then I'll have the correct structure. Switching 2 groups gets you the enantiomer. Okay, that's it.